Hello, I'm Mark, and welcome to my Unreal Engine tutorials on how to add support for wheeled vehicles into our simulation component. So this is a multi-part series on adding wheels into our simulation component, and it's a multi-part series of a massive playlist, I guess, on physics movement in Unreal Engine. And so I think today I want to do something a little different. So in the first video we did mass simulation, being able to set and move the mass of our vehicle. Then we created an engine simulation so we could translate controller inputs into mechanical torque, and then we created it. Then after that we did a transmission to take mechanical torque and turn it into angular rotation and angular position. And then we did steering simulation, so we could move the wheels, so we could start to move, so that we're ready to move a vehicle. So what I would like to do in this video is take a step in a little bit of a different direction. So now we're kind of getting to a point where we need to start having the rubber hit the road. No pun intended on that, but the metaphor, I think, does fit what we're trying to do here. So moving forward, we're going to be we'll want to get into suspension and into wheel into the suspension physics and the wheel physics. And in order to do that, we also want to then link that into the animation engine. So what I would like to do is take a little bit of a different approach and go ahead and focus on setting up our system so that we can support skeletal mesh animation, since that's what I'm going to be using here. But it should also help us support any other animations if we wanted to do it through statics as well. So that's what we're going to do today. We're going to focus on setting up the C++ animation stuff, and then probably in a follow-up video we'll then go ahead and set up the vehicle, so that we can then, once that's all done, we can then start to get a lot more out of setting up the suspension and the wheels. It'd be nice to be able to set that up and then immediately kind of see the fruits of those labors. So, as always, we've got a lot of ground to cover, so let's get started. Okay, so let's get started. So the first place I'm going to get started on is the simulation configuration. So here I'm going to want to go ahead and start making a setup reference for wheels, since everything's really, when it comes to the wheel system, is really revolved around that wheel. All of the other setups we've done so far for engine, differential, transmission, and steering, again, they're more supplemental support on being able to take the inputs and ultimately sending that to the wheel. So I think now's a good time to try and put that wheel in there, and that wheel representation, which is ultimately what we want to get to. So to do that, I'm just going to go ahead and just bring this over and make a couple of changes so that it all lines up with this solution. So this is the physics wheel setup. So this is the actual setup that I'm going to be using to manage the wheels, or allow us to go ahead and create wheel representations for our vehicle. And this is just a struct. We've got two things going on here. We've got our wheel class. So in this one, each wheel is actually going to be its own object, and within that object, that's where we're going to be running the simulation. So we have a wheel class, and then within that wheel class, we have two structs. One is for the wheel simulation, and then one is for the suspension simulation on that wheel. And that's how we're going to be doing it in this version of the solution. So physics wheel setup, again, location offsets. It's all, as I've kind of been working with third-party meshes, it's always good to, you're always going to need these offsets in order to make sure everything lines up in the right place. But again, so that's the offset. And then as far as properties, we've got the tag, and is it enabled or disabled? And so if this is disabled, we'll probably just we just won't include the wheel. Again, class, because now we're working with a U object, So we want to use, so this is a good way for us to work with other objects and bring them in. It's also a good way if you know, now that could be an object or it could be a blueprint too. So this is kind of a very useful little thing if you want to have subclasses within something and you just want to loosely link them together in Unreal Engine. Just use the subclass of and then the type that you want to use. Again, location, location, location. Everything about physics and physics movement is about location. So we're using our force location configuration struct again. You know, this has become a very highly reusable structure. And then finally, as part of this, we have a index. So what we're going to be doing is we're actually going to be creating, unlike some of the others, we're actually going to be creating objects. And we're going to have these structs and we're going to have these objects, and in order to find the object by name, which is here, we, you know, in that array of instantiated classes, we want to have a system to be able to map that. So when we create this wheel, we're going to put it into an array and we're going to say this wheel is in this array on this index. So again, this is just an internal tracker to allow us to be able to find that wheel when, you know, based, you know, if we need to iterate through this to go and find what we're actually looking for. So it keeps the struct here synchronized with the actual implementation, and we'll get to that in the next file. So in the next file, we're going to go to the vehicle simulation, back to our friend the vehicle simulation components. And in here, I'm going to do a couple of new add a couple of new things as we're kind of setting up to support the animation. So the first one is going to be here. I'm just going to bring in the comment too, so you can kind of get an idea of what we're doing. So this is actually going to be a delegate that we're going to be creating. So there's a couple of ways you could create delegates or reference them. So if you're creating them, we can create multicast delegates, and I've kind of done those in other shown you how you can do that in other videos. But then there's also the delegate handler here. So if there's a delegate in something else that we want to also then reference here, we can then use it for the delegate handle. And so this is going to be an mesh on physics state change handle. So whenever the mesh actually changes, so the delegate is actually in the mesh, so we're going to be creating a reference to it, attach it to this, and then from there, if that delegate fires, then we want to be able to go ahead and fire something. So this is just the handle reference that we're going to be using. So got that up there. We will get to that in very shortly when we get to implementation of setting up for skeletal meshes. Next, we created our wheel setup structure, and it's a very simple structure. There's no data in there because the data is actually going to be in the blueprint for the wheel. But again, so what we're going to do is we've got the property, edit, and then here's just an array of wheel setups, and we're just going to be using wheels configuration for that. So real simple there. So that gets us closer to wheels. Then I'm just going to come on down a little bit, and let's go ahead and add. We got one new function we're going to be adding, and I'm just going to add it actually down here since it's a support. It's a support function, and this is going to be our skeletal mesh setup. So we're going to be, because I'm going to be using a skeletal mesh, and I want to use some built-in functionality within Unreal Engine, especially for the suspension system. There's some things that we need to do on skeletal meshes if we want to do suspension on skeletal meshes that we need to go and set up first. So I'm just going to add this in. So it'll do a detection for skeletal mesh, and then if it's there, we'll go ahead and do it. And again, we'll get to we'll really go into a lot more deep dive around this additional things to this function later when we get to suspension. But we need to do a couple of other things here first, just to kind of link it to the animation. All right, and then let's see. I'm just gonna go through my solution, and I think we do need another reference here. Okay, no, we got instanced wheels, which is what we want. Do we have a function to see those instance wheels? Though I don't think we do. No, we don't. So let's go ahead and do that. That's probably the last little function that we need to add. So yeah, there it is. So let's take a look. Get current wheel state, simulation state. I'm just going to add this down here. And again, I'm just using a different name on my... Alright, so what this is going to do is this is just going to allow us to access that instanced wheel state, because that's where our wheel data is going to be stored and executed. So let's go ahead and fix these so that we can start setting up the implementation. Alright, I put that in the right place. Let's hopefully say this is going to go in the right place too. Looks like it. Cool. Alright, so let's just mosey on over to the implementation and just set this up. So don't need to be in here, and we don't need to be in apply inputs since we're not doing inputs today. Still not getting to the create setups yet, but we're getting closer. But what we do want to do is, okay, so we have in the begin play, this is where we're going to create our environmental setup. We create our thrusters, control surfaces, and buoyancy. So this is where, since I actually have that function, I'm just going to go ahead and do that. I'm going to put our create wheel setups down there, and then the last thing that I want to do, and I'm going to put a note in here as well, to drive the point home. If we're using skeletal meshes, we want to make sure that we're going to be doing this function last, because what we need is the data that this system is eventually going to create in order for us to start creating the skeletal meshes and do our final post-processing to support skeletal animation. So that's going to be there. So that is our begin play. Create wheel setups, not going to do anything there, but we have two new functions. So skeletal mesh is the next one, and I'm just going to go ahead and we'll be coming back to this function very, very shortly. I'm just going to stub in some of the basics first. So in anything in skeletal mesh, so since we have a skeletal mesh and we have this handler, we're just going to register on physics creation delegate. So there's a delegate in here. We're just going to go ahead and register ourselves with it. There's a function to do that within this mesh, so it makes it a little bit easier. So all we need is the handle, and then on that we're taking the on skeletal mesh physics create. So again, there's this static function here, create uObject, and what we're going to end up doing is we're going to, again, like any creation of on a delegate, right, we need a pointer to the component which we're going to be pointing back to. So this, so we're going to be using the this pointer for this instance of the component, and then we have this function called recreate physics state, which is part of our vehicle simulation component. We did that a little bit, probably centuries ago at this point when we're setting it up. But we'll be re-referencing this because if there's a change to a skeletal mesh, we do really want to recreate that physics state. Just in case anything changes, like the weight changed or anything that could affect the physics movement, we just want to make sure that if that happens, we can recreate the state based on that update to the skeletal mesh, so we can kind of stay in sync a bit more. All right, there is something else I want to add in here, but since we haven't created that class yet, we will come back to that probably by the end of the video. Again, there's kind of like some circular stuff that we need to do between, especially when we start working with skeletals, where we want to, there's information that we have here that we're creating that I actually want to send to the animation blueprint, and process it for the animation blueprint so that it's a lot easier for me to then retrieve it from the animation, when we're in the animation blueprint, to then enforce it on the vehicle. So we'll do that there. So we'll come back to that. And then there's also some additional things that we'll get to in future videos when it comes to setting up suspension systems on skeletals. Some pretty neat things in Unreal Engine that Unreal Engine supports under the hood for that, so we'll get to there. And then finally, I'm just going to go ahead and add this, since we might as well. And then finally, I'm just going to add this little function here. So on the mesh, if for kinematic bones update types, we're just going to tell it to skip the skip simulating those bones. So we're just going to use that. That's the final setup. And then last but not least, we have our array here. So this is important because our animation engine is going to want to, or the information that we're going to be calculating in there is going to need access to our wheel instances so we can get that information out. So that's all this function is. It's a const, so it's read only. So, and we're just going to be accessing the array of wheel objects. So again, and that's why we've got the little pointer there, because these are objects, not structs. All right, so I think that should, I'm just going to bring this up a little bit for now. We've got the steering wheel. I'll probably just minimize that since we don't need to be back in there for a while. Okay, so I think that that's going to do it for here for now. We will come back. So there's some more setup that we need to do, and now, so let's move over to the vehicle, the wheel, the vehicle wheel, so we can get that set up. Okay, so now we're in the vehicle wheel component, and this is where we're going to be setting up all the information we need for our simulation for our wheels and suspension. So we had previously we went ahead and created our we stubbed out the wheel simulation setup and the suspension. Again, we'll just stub this out real quick. And we also went ahead and, because we needed some information here to start linking into, so we can start the link up between the engine and the transmission and the wheels, as well as the transmission wheels, and any suspension information we need. So we started that. We've already started that process, but we haven't really finished it yet. And then also in doing so, we also need to have a reference to our component. We also need to have any offsetting that we might want to tweak for these wheels, and then we have a rotation point and wheel index. So let's go ahead and at least we're going to finish this class off, so that we can then use this to kind of link that into the animation engine when we need it. So to do that, let's go ahead and bring in some functions so that we can both initialize and retrieve data from this class and any structures that this class is using. So all right, so I'm just going to bring these functions in, and it seems like Visual Studio's AI is brain dead, so we'll just have to go and fill these in the old-fashioned way in the implementation file. All right, so again, we have an initializer. We also have shutdown, and these are virtual, so they can be overridden. We also have a getter and a setter for the wheel index. We're going to be using this a lot. We shouldn't really be using this much at all. Set rotation point. This is very useful. Again, as we continue, when we go from the setup and start to create these wheels, we'll need to know what bone we'll be rotating around for our wheels, as well as what bone we're going to be using for to determine what we have to move and what bone we need to move and rotate in order to facilitate the animation on that skeletal mesh. And this could be for skeletal meshes. The rotation point could also be for statics too. You just, it's just a more manual process because we have to do that within the blueprint versus using the animation engine. But again, all that information is there. wheel index. So because we actually have we have the struct, which has the setup, and then we have an array of objects, which is where the simulation is. We just need to have some way of making sure that those two arrays are synchronized. So that's what we're going to do there on the wheel index. And then get steering angle, again, get rotation angle. So steering angle is going to be our yaw. Our rotation angle is how much, the angle pitch on the wheel as it's rotating. Suspension offset, this is kind of where our suspension is, where we want to move the bone, right? So the first, this one and this one is going to be where is going to be the rotation on the wheel. This is going to be the bone placement along the z-axis for the suspension. Then we also need to know which direction the suspension is going to be going in. So that's that information. And then we'll have a little boolean here to see if we're actually in the air or not. And this again is in air. This should be relevant mostly to whether the wheel is in the air, not the vehicle is in the air. All right, so now that we've got this, let's go over to the implementation file. So that's under vehicle wheels implementation, and all implementation is in the private folder here. So now that we're in here, so previously when we created this class, because we're using this generated uClass body macro, it's going to want to have this constructor here. If it isn't here and we try and compile, we'll get a compiler error, so we just need to add that. All right, so let's go ahead and add the implementation. So the first implementation I want to bring in is going to be our this is going to be our reference to our vehicle simulation. And so again, this is the initialization function. So we're going to be passing in the vehicle simulation, and then we're also going to be passing in the wheel index on the initializer. And then what we're going to do is we need to do a validation, and it looks like we probably don't have this function here yet in the components. So I'm actually going to head back to that back to the simulation component and add this missing function. What this does is it just does a check to make sure that this index is valid within the array, so that we're all linked up. So let's go ahead and do that real quick. All right, so let's see. We're going to come here. We need to add a function. So I don't need this function to be blueprint callable, so I'm just going to add it right here, but it does need to be public. So it can be accessed, and all it is just a simple little validation check. So I'm just going to add that here. So it's just a simple is wheel setup valid. It's going to take in the wheel index, and it's going to check it against the array, since the array is actually in this class. So we'll just make sure that the indexes are all still valid. And let's see if this Visual Studio is going to. All right, yep, it'll put the function in the right place. So let's go ahead and just implement that. And I'm just going to do this. So on the array, on these array structures in C++, it actually has a nice little function called isValidIndex. So you don't necessarily have to go and check to see, so this will do the check for us. It's gonna, whatever, if we put an index in, isValidIndex will allow us to see if that index is within the scope of the array. So if I put an index which is out of the scope, it will come back false. Otherwise, if it's within scope, it'll come back true. So we can use that index. It's a nice little check that they've added into the TArray struct, so that you can check to see if the index is valid before you try and use it. You could also just say, take the array, look at the number. Is the index greater than the number? If it is, or if the index is less than the number, right, then it's true. Otherwise, if it's greater than the number of elements in the array, then it's false. But we can also use this one too. And so I'm just electing to do that. Keep it simple. All right, so let's come back, And I think we're also missing a couple of includes, so let's go ahead and do that real quick. I'm just going to go copy these in. I think they're in the same place. I'm going to add the UObject constructor helpers. I don't think we're really doing too much with this, but I'm also going to add the add this function in here, or this include, which is a reference to the vehicle simulation component, since we have a pointer reference here. So I'm putting it in here. That way we don't, since we don't need it in the wheel up here, right? All we're using the class as a pre-constructor here and here, so we just need to make sure we reference it there, and that'll prevent us from getting any circular compiler errors. All right, next up is going to be the get steering angle. So let's go ahead and add the steering angle. So this is going to be the steering angle that we're going to be using. I'm just going to take that out since we're using that instead. And the steering angle's in our wheel profile. So again, as we're going through, we're going to be checking, and we want the steering angle for every wheel, so whether it's steering or not steering. So we want to know what the actual angle of each wheel is. And so in the steering simulation, as we saw before, if there is steering on it, we set the steering angle to whatever the angle is, or whatever we've calculated that angle to be, and we apply it to each wheel that has steering. Otherwise, if it doesn't, we set that to 0, 0, just to enforce that that wheel is still going to be in the that your angle is still going to be 0 for that wheel. All right, so that's what we're doing there. And that's calculated on each wheel. So then next up is going to be our get rotation angle. So this is going to be the angle of rotation that we want to apply, and this is going to be our pitch over angle for the animation. So yeah, steering angle is our yaw, and so the next is going to be our pitch over. All right, so let's go grab this real quick. And again, I'm just going to go fix this a little bit. So, okay, so we do need to add a new function to our wheel profile as well. So this is get the angular position. But I'll just go over this real quick. So what we need is the angular position that's being calculated within the wheel simulation. Then we want to take that angular position, and that angular position is going to be calculated in radians. So we need to translate that from radians to degrees, since that is what the animation engine and Unreal Engine is going to be using to rotate. So what we're going to do is we're just going to go and there's a nice little fmath function which will allow us to translate from radians to degrees. Once we get the degrees back, we'll multiply by -1. And then, because that will indicate the direction that we want that angular position to be going in, and then and that'll give us the rotation angle. Then we'll do another test to make sure that that rotation angle is not nan. All right. So this, we actually get a value. If we get a value, then we will. If it's not nan, that's what we're doing here. Right, for this another little fmath function. We'll then go ahead and return the rotation angle, and this is the angular position that we want that wheel to be in per tick. And if it is, we'll return 0. So because effectively it should be in the 0. It is 0. All right, so let's go ahead and go into wheel profile and stub this out real quick, so we can then start tracking the angular position. Alright, so all that information is hiding in our wheel simulation setup, so we're just going to click into here. And as you can see right now, we do have some information already for wheel simulation setup. So let's go ahead and start adding some additional information. So omega, torque, steering angle. This is all the information that we've been collecting for both engines and steering. So let's go ahead and add the values that we want. This is the values that we ultimately want us to drive our, to go ahead and drive that information for our animation engine. So I'm just going to grab this and let's see, I'm going to just put this up here and I'll put a little note here. So as you can see, I'm kind of including some notes. So this is again, Omega is in radians per second. This is just how Unreal Engine's calculating it, so that, you know, if you need to make any changes, or if you're kind of working on this and wondering why certain things aren't adding up, you may need to do some conversions between radians and angles and radians. So I'm just going to add these little notes in here, and I'll probably do the same thing for steering angle too. So I'll just go ahead and just, so steering angle is always going to be in degrees, yeah, so there's no changes there, but angular position will be, when we run the simulation, we'll be calculating that in radians, so we'll then want to translate that back into angle. Alright, so we have the getter and the setter for the steering angle, so I think we just need a getter, because this is going to be something that we're going to be running when we run the simulation. This is going to be the product of the simulation, one of the products of the simulation. So let's go ahead and grab this. And I'm just going to go ahead, let's see, we'll just put this right here for now. Again, this is the angle position. So the simulation is going to run when we get to that part, and one of the products it's going to say is this is the continued position, and this is going to continue to be updated. So it's going to go through all the way through 360 and then back to 0, and then keep going and going and going. So this is how we're going to be calculating the spin on the wheel per frame. And that is, again, that will be how much spin, you know, where we are per frame as we're ticking along. All right, so okay, so that should satisfy that. So if we come back here, there it is, angular position. So again, so that's in radians, so but we want it in degrees for the animation engine. Okie dokie. So moving along, next up is going to be the, so we have rotation, we've got steering angle, we've got rotation angle. So I think, what is it, next up is going to be, so steering angle, suspension and axis, and then in air. So let's go ahead and just finish those up. I suspect I've got another function that we're going to need to add into the offset. So let's take a quick peek at that. Yep, so we'll go into suspension profile and add this one in there too. So again, this is the get suspension offset. Again, this is going to be this is a product of the suspension simulation. So just like get angular position is a product of the wheel spinning simulation, right? We also need the suspension offset, which is a product of where it wants to place the resting position, right, of the of this, of the wheel bone, within the suspension simulation that it's running. So let's go ahead and add that as well. All right, so let's go back to our wheel simulation setup. So in here we have the wheel simulation setup, but we also have the suspension simulation setup too. So let's go ahead and add those missing pieces in here. Again, when we get to suspension, we'll fill out and we'll get this completely filled out. But for now, I'm just gonna make sure, add the pieces that we need in order for us to satisfy our the animation piece. So again, these are going to be the products that we're looking for. So I'm just going to go ahead and copy this over, and I'm just bring it in, and it's going to show that we need a couple of pieces of information. So, again, this is the simulation product. So we need this simulation product is going to be based on the get spring length and based on the suspension max rise. So let's add that variable. And so suspension max rise is a variable that we put in, and again, this is going to be in centimeters. So this will be one of our first variables. So let's put this in for now. So suspension max rise. So this is something that we'll be able to set. This is the amount of rise that we can get from the vehicle. And then we also need max drop as well. So I'm just going to bring this in while we're there. So this is the rise and drop of our suspension. So this is the distance that we have. So rise is from the origin up, and then the suspension max drop is from the offset down. So the local offset, this is kind of what we're setting as the local resting position. So when the suspension is in neutral, this is the position that we want to be in. And then what we're going to then do is calculate based on, are we going high or are we going low for our suspension. And I'm also going to add in the hardening stiffness as well. So I'll just get some of these properties in. And we're going to probably need the suspension access as well as the suspension offset, any suspension offsetting as well. I'm just going to just bring all these variables in that we need. So again, this is the axis. So this is our suspension axis. It's going to be on the Z. Yeah, this suspension is only going to be going up and down, and we're setting it to negative. And that's the, as far as the direction that we're calculating in. So we're not calculating up, we're going to be calculating going down into the ground. Again, this is any suspension offsets that we need. I'm just going to set this to 0. And then the only other thing we need is to get the spring length function. There's going to be a lot more information, a lot more variables that we're going to be doing to tune up the suspension for the suspension simulation. But I figured we'll just go ahead and just bring these in right now. So the function that we're missing is the get spring length. So let's go and get that. Real quick. So there's the get spring length. I'm going to just bring this down here a little bit. So that'll satisfy this. And let's see if we can go ahead and add that function real quick to the suspension system. So let's go find the implementation. All right, so there's no implementation code here, so we might as well just go ahead and see about filling that out. Actually, looking at this right now, you know what, I'm going to hold off on that because yeah, we'll just keep this stubbed out for now, and we'll come back to this. I don't want to get into this because this really now gets into suspension and suspension smoothing and a lot of other things that we want to put in there. And again, we'll get to that when we do the suspension, but I'm just going to put the hook in there just to satisfy the argument in this function. Again, I don't want to kind of go out of the scope of the video. So we'll be adding a lot of things into here, but the idea is that we want to pretty much return a value, and this will be the location, the ultimate location based, in relationship to the max rise, or the max rise of the suspension. So we'll talk about that. So let's just finish this real quick. All right, so I'm just going to hit save, and we'll come back to this when we're ready to come back to it. All right, so that just satisfies that. Now let's go back to the wheels. So as you can see here, so again, as far as the finished product, we need this, and then we also need, the axis. So that's this is the direction. And that's going to be useful for when we go ahead and make the calculations for the animation. And I'm also going to go ahead and get this one for is in contact. And that's one more function we just need to add. So let's go back to wheel setup, and I'm just going to minimize this and bring out the wheels again. And let's go ahead and just grab that real quick. Alright, so that is just a function to say if we're in contact or not. Where is that? Alright, so for that, so we're back to the wheels. I'm going to add another private variable, which is our in contact. So as we do our wheel simulation based on several things that we're doing, and based on suspension, the suspension is going to say whether we're in contact or not. That needs to then be fed into the wheel, because that is what we're going to need to know if we're in contact or not to determine how much thrust the friction forces are going to generate for our wheel. So we'll be pulling that off here. It's just a little Boolean function, and then we're just going to create a little function. Well, it's a little Boolean variable that we're going to be setting, and I just need to then go ahead and get that back. So I'm just going to add that in there. So that's our in contact. So that's the last thing we need to know if we're going to be, on our wheel setup. Alright, so that satisfies everything there. Alright, so that's everything for wheels and the wheel simulation stuff. So with that out of the way, we should have all the things that we need in order to go ahead and create our animation or extend an animation blueprint, so that we can allow it to do all the, create all the finished post-processing for our bone setups and bone manipulations. All right, so let's go ahead, and so that should do it for this. Just double checking my work, make sure I'm not missing anything. Okay, so next up we're going to go into the we're going to need to go back into the physics movement our solution, and we'll go ahead and we need to create a new set of functions for our animation. So let's do that. Alright, so let's do a compile. Make sure everything compiles first before we try and add a code. Oh, no, it looks like we have a compiler error. Let's see what, I'm just going to go check the log. Oh, looks like I forgot to add the shutdown function. So we defined it, but I did not go ahead and do an implementation. So let's go ahead and do that real quick. Just going to go copy this function over here. Let's go back to our Visual Studio. So we're back in Wheel CCP. Just going to go add this missing function. This should satisfy the compiler for us. So let's just do that. Hit that, and we'll do a quick little, we'll go and recompile, and this should satisfy that argument. Alright, so let's go ahead and do that. I'm just going to go compile it. Alright, good compile. Alright, so now let's go into our C++ classes. Here is our folder, movement and simulation. I'm going to add a new folder for animation, and so this is where I'm going to be putting our animation blueprint code. So something that I like to do is, especially when working with a lot of animation stuff and creating a lot of calculations for animation, is to actually take a animation blueprint class and just extend it. It just allows me to kind of I can create custom functions and things in C++, and I can also then tie it back to the actual modules that I need it to tie back to, and just makes things a little bit cleaner when we start getting into the actual blueprint itself. And so that's what we're going to do here. So to create a custom animation blueprint, I'm just going to right click and go to new class, And we're going to come to all classes, and we're going to go and find the animation blueprint class. So let me go grab this real quick. So that would be under, I think, anim instance. There it is. So this is the class that is being used by all the animation blueprints. So what I'm going to do is I'm just going to take this. We're going to create a custom version of it, inheriting from that whole system, and then that will allow us to then add any additional like helper functions or system or processing functions that we may want to do between the simulation code and the animation blueprint, so that we can try and keep those values up to date and in sync as much as possible. So that's what we're going to do here. So I'm going to hit next. I'm just going to go and copy this function over. So this is going to be the physics vehicle animation instance. This is under public, and I'm just going to go and put this into a new folder. That way keep things a little bit organized. And I'm just going to call this animation so I know what's in it. So once that's done, it's in public in the right runtime. So let's go ahead and create it. And once Visual Studio's done its thing, we should have a generic inherited animation class that we can work with. It's almost there. Just doing another compile. Alright, great, wonderful, we've got it. So if I come into here, Physics Movement Live, public, there we have the animation. There's our new blueprint animation blueprint class that we're going to be just overriding. Alright, so let's go ahead and do that. So I'm going to just minimize this, come back, and here is our new class. I'm just going to say reload. Alright, so I'm just going to do a little housekeeping here and just make that transient. And I'm also going to add so instead of using the generated body, I'm going to use a very specific generated body, which is the U-class body. I'm just going to put some space between that, since we're going to need some additional includes. So we have the I'm going to add in the UObject macros as well. And in order for us to be able to calculate this stuff, I'm going to be using an animation instance proxy. So we're going to create an animation instance proxy, which is going to be doing all of the pre-tick animation work and then so that's going to process the data coming that we want to take out of the simulation, i.e. the product of the simulation, process that. And so I'm going to do that. We want to do that on pre-tick in there, so this gets calculated before the tick of the animation engine ticks, so that when it does tick, then we'll have all the information that we need to start feeding the bone manipulation code in the blueprint. Alright, so I am going to go ahead and do a couple of other things. So the first thing, one of the things I'm going to do, we are going to need a reference to our simulation component. So here I'm just going to put the class. This is a pre-definition. So if we are referencing this anywhere in further down, the compiler will know that this is going to be the include file will come later. And this is again used to help prevent circular logic in the compilation process. So that's why I'm going to put that there. Next, I'm going to need a structure. So I'm just going to go bring this structure in. And this structure is going to be my physics bone animation data structure. So this is going to be a little structure where I'm going to say this bone is going to have this rotation and this location. So this can be very useful for just reorganizing my rotation and location data by the bone name. So that's what we're going to do there. And then next, I am going to need to create a animation proxy class, and this is going to be where we're going to be doing all of our animation. This is where we're going to be running any additional animation calculations that we need to do. So, and let's just go ahead and make sure it's using the right API. So here, again, this is a animation proxy. This is inheriting from animation instance proxy, and within the proxy we have access to this function, which is what we need, which is the pre-update, and that's done on delta seconds. And this is where we're going to go ahead and do any processing so that we can take the animation data and fill it into this structure here, which we can then use to access, so that we can create our bone to rotation and location mappings in the blueprint. And then we have the set physics movement component. So this is the component that we need to reference again. So the proxy is going to live within the actual animation instance, but the proxy is going to be pulling its data from the vehicle simulation component through the added functions that we just added in there. So it's going to be a little bit of a tight coupling, but that's okay. And then ultimately what we want is to be able to create an array of get wheel animation data. So this is the array that we want to bring back. And again, this is running in the proxy, so then this needs to be bubbled back up to the animation instance so that we can get access to this data. And then again, here's the wheel bone instance. And again, it's just an array of these structs. All right, so that should do it for that's going to do it for setting up the proxy. I'm just going to go ahead and let's go ahead and define the animation instance, and then from there we'll go back and start doing the implementation for the proxy and the instance to kind of finish this up. All right, so in the class, let's go ahead and just create my public and private sections. All right, so I'm going to go ahead and create I'm going to need, keep this in public for now. So first off, we're going to need a map of name and transforms. So this is the actual information that I actually want to make available to our, ultimately what we want is the name and transfer form. So we're going to be taking information based on this information here, and then we'll go ahead and put it into a nice array based on the bone name and the transform data, and then from there we should be able to pull it up as we need it. As it's being updated in the map, we should be able to then pull it in the animation engine and read that data. Next up, a couple more public functions, and so we have the physics movement component here, and this is a reference to the physics movement component. So let me just take a look at this. Vehicle simulation component, physics movement component. All right, so that's going to be, so this is going to be an internal variable that I need to add in the private section. So we'll come back to that and fix that red squiggly. Let's just get through the public stuff first. And all right, so I'm going to add a function here called update bone transform. So this function here is a function that I'm going to be using to update the transform data. So what we'll be doing is we'll be going into the proxy, getting the finished data out of the proxy, and updating this data so that we can then pull it out. And then I have another function here which is actually going to be used within the animation, so there's two places where we can call functions, right? We can create functions and call it in the event graph. And that doesn't necessarily have to be thread safe. That's kind of information that's being calculated on one thread, so that the animation engine can use it on the other thread. But then we also have the animation graph. And so one of the things in the animation graph, if we want to create a function that can be used there, is we need to make sure that that function, though, has to be thread safe. So I'm going to make this a blueprint pure. It's going to, and in order to make that function thread safe within the animation graph itself, we need to add this meta tag here, which is blueprint thread safe. So this function is, I want to call it in the animation graph because that's where we're going to be applying the bone transform data. So it's going to go in, find what I need, park it in there, and we're good to go. And then as far as private functions, I'm just going to go grab all of these. So I'm going to be overriding the native initializer. I'm also going to be overriding the native update animation. Probably won't do anything on the destroy, and because we're using a proxy, we need to override the create animation instance proxy. So again, this is our proxy code up here, and this is the reference to that proxy code. So you could technically have multiple animation proxies if you've got lots of different animations that you need to be tracking within this blueprint. But I'm only going to be using one here. But at the end of the day, we definitely, as part of, and these are all virtual, so these are all being run within the context of the actual class here. And by going, but we're going to go ahead and override it so that we can add our own code into there nice and cleanly. So, all right, so let's go ahead and set this up. So I'm going to come back up here and we'll start with the proxy first. So I don't need to do anything with the structure. So let's go ahead and fix these real quick. So show potential fixes. All right, you are going to put that in the right place. Okay. All right, so I'm just taking a look real quick. I'm going to need a constructor in here. Let me just double check the animation proxy. Generate U-body. All right, so when setting up the animation proxy, something that we need to do in the implementation file is animation proxy has a couple of overloaded constructors. So I'm going to go ahead and define those up here. So again, this is the physics vehicle animation instance proxy class that we're creating, right? And so we actually have three constructors. This constructor is on the super, this constructor is taking the animation instance in and passing it in, and then this one is just the default constructor. Actually, I don't think we need this one. We just need the two ones up here. Again, because we've got this, so this is F animation proxy, this is the instance. So those are the two constructors that we need. That should satisfy that and that. There they are. Done and done. So then the next thing we need is the pre-uptick. So this is, again, because we're inheriting from animation proxy, each proxy is going to do a pre-update. So we want to tap into that pre-update through virtual void and override. So let's go ahead and do that. Just going to go show potential fixes. And I'm also just going to go ahead and do the set physics movement component and just get that out of the way so we can get all the proxy code out of the way. So set physics movement component, let's just go ahead and just copy this real quick. And then we'll get into the update proxy code. So this is using the physics wheel setup. So we need some includes. So I'm just going to bring these two in. Oh, looks like we need another function in the component called the get wheel setups. All right, so we'll go ahead and add that function in there too. So as you can see here, this is allowing this is going to allow, since we're passing this guy in, right, this is a reference to our vehicle simulation component, so the proxy on setup is going to go ahead and generate these wheel bone instances, and so it's going to create these, or we're going to create this array in the and kind of like pre-create it. That way we have a constant set of bone setups that we need for each wheel, and then when we go ahead in the tick, we'll add it into the right position of the array. Again, this is where it gets a little bit interesting because we've got to maintain a lot of these indexes. We don't want arrays to get smaller and larger. We need it to stay a constant size. We have, for the vehicle that I'm using, we're going to have 8 wheels, so the array needs to be of size 8 all the time, and we also want to make sure that each one in there is in the right place. So again, it's trying to keep everything in sync on the when we construct it, and then we need to make sure that we double check to make sure that nothing has got things out of sync, because if it has, then we need to kind of reset some things, or we need to prevent something from firing, otherwise Unreal Engine could crash, so it gets a little dicey here. So all right, so I need another function called the get wheel setup function. So let's go ahead back to our simulation component, and let's go ahead and add that in real quick. All right, so back in our vehicle simulation component, I'm just going to come down, and again we need to create another public but non-blueprintable function, and this is the get wheel setups function, and all this is going to do is it's just a reference back to our wheels configuration. These technically, that's protected, right? Yeah, it's protected. Yeah, so since this is all protected data, we need to make sure we just have a reference here so that we can get this. And again, this is constant, so it's read only, so data only goes one way. And all this is just an array. We're just passing back an array of the wheel setups that we have created up here, that we just added. So this allows us to try and keep, because that's where the bone information data is located, so that's why we want a reference to that. And again, since we're going to be creating our setups off this array should then be in sync with this array. So the wheel, if a wheel is in position 0 here, it should be the same wheel that's in position here, 0 here. So again, when dealing with a lot of this wheel joint stuff, it is tricky. We just have to try and keep things together. All right, so now we're going to come back, and that satisfies that argument. So again, this is just the setup. So this will get fired on the setup. So when we call this in the so that's going to get done around here, and then that's going to pass this back into here, and then this sets us all up, so we have our array ready to go, so that we can now get to the pre-update function being run in the proxy. All right, so again, simulation proxy is being overridden, so since we're overriding it, let's go ahead and add the super function. So what this does is it says when this runs, it's going to run the function, the update function first on the derived, or the function that or the class that we derived from, and then we're just going to go ahead and run this. So I'm just going to let's bring this in, see if we're missing anything. Physics vehicle animation instance, physics vehicle animation instance. So let me just double check this real quick, make sure that we're all good. Oh, I got a W there, so I'm going to take that out. I think I just copied the whole name over. So yeah, so we just need a single U here. Again, Unreal Engine likes to add these little prefixes. So a U means it's an Unreal Engine object, and F means it's an Unreal Engine struct. So kind of get a quick idea of what is what. All right, so okay, so that should fix that. Yep, there it is. All right, so what's going on here? So first off, we want to make sure that we're going to take the animation instance and we're going to cast it to make sure that this animation instance is still good. Since this is a struct within a class, we're just doing some due diligence here. So again, we're taking the animation instances that's being passed into here, and we're just going to cast it, make sure it's all okay. If it is okay, then we're going to say, okay, go into the animation instance and get the physics component. So this is our physics component. This is the simulation component that we created that is going to house our animation data. Then from there, within there, in that simulation component, we have a function that we added called the get wheel instances. So if we were to go to here, and let's see, get wheel instances, where did I put that? There it is, it's right here, get wheel instances. So we're going to be calling this guy, which is going to have all of the product, which is where all the product data of our simulation is going to be. Right, and from there, we're just going to then, so this is a for again. So this is an array, and this is an object. So we're going to be doing a pointer reference, and so here's our wheel. So for each wheel in the wheel instance, we're going to go ahead first, make sure that the bone instance information that we set down here, this array and this array are equal, right, in the number, and that the index that is being set in here is a valid index within this array. Again, we just want to make sure we want to do all of our validations so we don't get an index out of array error. And then if everything looks good, then again, physics bone animation instance. So this is the physics bone animation instance that is sitting in this guy here, and that's why again we've got an ampersand. So what we're going to do is we're going to go into that array at this wheel index, and we're just going to pull that out by reference. And by doing that, what we don't have to, that way we don't have to pull a copy out and put a copy back, and it also means that I don't have to keep doing this every single time for each one, for pitch, roll, yaw, and offset. I just have to say, just give me the referenced instance first, and then we'll just update it, knowing that this is actually being updated within here, and all this is just a reference to where it is in here. So we're just updating within the array. It's just another way of doing it. But yeah, so then what we, again, this is the angle, this is the get rotation angle, again, a product of our wheel simulation. And again, we will be doing a wheel simulation on each and every wheel within our vehicle. And then this is the steering angle. And again, this is coming out of each and every wheel. And then as far as roll, we don't need to worry about roll offset. So rolling is kind of, really wheels should only be pitching and yawing. They really shouldn't, unless the wheel axle is broken, we shouldn't be really adding any roll to that wheel. So we're going to set this to 0. Now, you may want to have some roll on that wheel, I guess, if you wanted to kind of, have it in your simulation to be able to roll in or roll out the wheels, depending on, if you really want to get into race car setups. But for now, we're just going to keep it simple. And then location offset, again, this is the suspension axis, axes, I should say. So that's suspension axes, and we just multiply that by the get suspension offset. And then again, we just take the negative of it, so, or the negative of the axes. So again, we're just going to multiply that. That's going to be the location, and then that location is going to determine how high or how low off the ground our suspension is, and that should then reset the bones if everything's working correctly for our vehicle. Alright, so that should do it for the proxy. So this is everything that's being done in the proxy on the pre-update. So now we can come to the actual animation instance, and then once we're done with the animation instance, we'll tie this again back into the simulation components. And so then this animation instance should then work with this component, with any vehicle that is referencing this component. All right, so let's see. Next up is set physics movement component, get physics movement component. That is pretty self-explanatory. I think we need to add this in. So, yep, we do. And Visual Studio has gone stupid on me again, so I'm just going to go ahead. It's probably thinking it's this function is the same as this function. Gotta love that AI. Alright, so I'm going to add this one in. So, actually, that's the animation instance proxy. Nope. We want the one here. By mistake. That's the one we want. So we have a set physics movement component. We've got one on the proxy, which is for the proxy, but we also have one here, which is on the movement. And as you can see here, when this one gets called, this is the one which is in the object, and then the first thing it does on the set movement component is it's going to set the movement component here, and then it's also going to then pass this over to the proxy, so the proxy can also set its reference to the movement component as well. Again, since we need a constructor because I'm going to be using the generate U class body, so I'm just going to go ahead and add this default constructor in there so the compiler's happy again. Alright, so then next up, this is an inline function, so I don't need to worry about that. So then we have the update bone transform data. This is a blueprint callable. I made this blueprint callable in case you wanted to call it from the blueprint, but if you add it into the native update animation, it'll be updated there, and so you don't need to call this in the blueprint. So, all right, so this is the update transform data. I'm just going to go ahead and just copy this and bring this over. All right, so this is kind of this is going to be done in the so when we're working with animation blueprints, right, we have the event graph, and then we have we have the animation graph. So this is going to be run in the event graph, or it can be run on here, the native update, which is equivalent to running it in the event graph, but we can actually run this from C++ instead. So again, what we're going to do is we're going to take our physics bone data from the that's being updated through the animation proxy. So this data is being constantly updated through the animation proxy. So the proxy is doing all of that animation update work for us, and then it's going to take that finished product, and again, this is going through data processing, and this is the final process of what we want, which is by bone name. And we're going to go ahead and either add or update the rotational offset, a transform with rotational offset and location offset. So again, data processing through data processing in order for us to get it into this nice map structure that we could then pull from. All right, so that is our update bone transform data. So the last one we're going to do here as far as public functions is going to be the get bone transform data. And again, this is a blueprint pure function I've made, and I've also made sure that it is thread safe, because this is the function that when we get into the animation graph and doing the updates there, this is what we want it to pull from in order to get that wheel position correct. Okay. So here it is. So what's going to happen when we get to the animation graph is we're going to put in a bone name, and that bone name is we're going to expect to get a transform back. So that bone name is going to go in. We're going to first check to see if that bone name exists. If that bone name exists, then we'll go ahead and bring it back by reference. So we're going to bring a copy back. Otherwise, if it doesn't exist, we're just going to give you an empty transform because we need to satisfy this argument. So If you're debugging and you're putting a bone name in, you're getting an empty transform back, it's probably you're using the wrong bone name, either in the animation graph or you're referencing the wrong bone name in the components when it does its mapping. All right, next up is the native initialization. So this is if you need to do any native initialization code. You can we can override the actually this is transform data. Oops. Let's go get the native initialization code. Come on. There it is. So here, this is the native initialization code. So, and you can do this in a couple of different steps. It all depends. If you want this to run before anything in the event graph, then you can execute it here and then call this. Otherwise, if you want the event graph to run before this code gets called, you would then just put this up top. So this is going to execute, and then the event graph, and then the initializer in the event graph will run. So again, this is just hooks in there, so we can kind of just take this code so we don't have to add it into the event graph. So again, this is going to go through the actor, find the owning actor. What this does is it's going to look for a component. This isn't always predictable, and so that's why we're going to go back to the component and do a secondary check. Because if the event graph gets called before this component is fully created in the owning actor, then this will not run. So it's not 100% accurate. So we will tighten that up. All right, next up is going to be the update. So again, in the animation graph, we have the ability to do on event updates. And that's where we usually add things in the animation graph to make calculations that are going to be used by the animation blueprint, right? So this is just a C++ version of it. And again, if we want to do it before the animation graph, then we just put it up front. Otherwise, if we want the animation graph to run first and then run our stuff second, you just you just put it behind the super. If you don't include the super, then it won't run. It won't tick the animation graph period. So we want to make sure that we add these in there. And again, same for native initializers, same for this. And then this is just the bone update. So again, on each tick of the animation graph, we're just going to make sure that we go ahead and get the most update data that we need to feed the animation. And then I'm just going to bring these two functions in to finish it off. So here's the proxy create. So this thing will get called again because this function always, again, where it's a virtual override, so the animation instance is always calling this function. So this is where if we have any proxies that we're using within the animation graph, we can go ahead and get these things called. And that's just saying, take the animation instance proxy, here it is, and it's just going to return a reference to it. All right, so that is everything we need. And we're not doing anything on destroy proxy since it's a struct. We don't need to worry about doing any destroying there. Okay, so the last thing we want to do here, just to tie everything together, we're going to come back to our skeletal mesh setup since animation engines are only used for skeletal meshes, and we just need to go ahead and close that loop. So to close that loop, I'm just going to go ahead and just going to grab this first. It's going to say, and it's going to give me a little bit of a red squiggly, so it means that we just need to go ahead and add an include. So let's go ahead and do that. So let's see if this works. So that's animation. Let's see if we can just. just need that U. All right, so there it is, animation instance. So what's going to happen is on skeletal mesh, we're just going to go ahead and run this set component. So we're just catching it in two places. And again, I kind of noticed this when I was working on another project, that there can be a little bit of a, which comes first. So sometimes the animation engine gets called, gets set up before this thing's finished setting up. And if that's the case, then it's not found. So what this is going to do is because we're going to call the skeletal mesh anyway, this will say go ahead and do it again. Since we're doing it again, it's not really going to hurt anything. It's just going to say go into the animation instance that is tied to this mesh and set up the movement component here. So that's where we can do that. All right. Okay, so I think that should do it for setting up the animation instance. And so I'm probably going to go ahead and just stop this video here. It's a pretty long video. And I think what we'll do in the next video is we'll go ahead, grab the asset, start setting the asset up, and then we'll go ahead and tie the animation stuff into it so that we're ready to kind of get into the more the fun stuff, which will be then simulating the suspension system in full, and then also simulating and then from there we'll simulate the wheel friction, which should then get us all the way to a wheeled vehicles. So, as always, if you like what I'm doing, feel free to subscribe to my channel and like the video. And yeah, I'll see you again in the next video. Cheers, and bye.